Hi everyone, we are moving on to skill number 8, and we are going to be talking all about functions and their domains and ranges. So as always, there's usually some things we need to go over before we get to our practice. We've got lots of really important vocab terms, so let's go over those first. The most important is what a function is. So I'm going to zoom in just a little. Now would be a great time to pause your video if you want to write down these first two terms, even the examples. But we're going to go through and decide if these four are functions using our definition. So a function is a special type of relation. So there's inputs, outputs, or x values and y values, but each input, so each x value, has exactly one output. That means, so when you see exactly in math, that means there's not 2, there's not 3, there's not more or less, there is exactly one output for every input. Okay, so what goes in must come out as one actual output. Let's see what these are. So first one, I'm going to see, is this a function? So I'm going to see every x value has only one output. So 1 has 5, 2 has 6, 3 has 7, and 4 has 8. Each one of these has one output. So yes, this is a function. Next one, we don't have a table, but we can kind of think of this logically. Now think, we just practiced in skill number 7 graphing something like this, and we know that it would be a perfect straight line. Every x value would have one y value, and we can just see that just by trying a couple. If we input 1 into this function, so let's say we solve this when x equals 1, equals 4 times 1 minus 2. So I've got 4 times 1, that's 4, and 4 minus 2 is 2. Now we have to think about this in the terms of functions. If I were to input 1 again, would I ever get anything else but 2? No. Every time I input 1, I will always get 2. So yes, this is a function. That would be true for any value. Okay, next one, we've got another table. And this is the one that usually tricks people, and I will tell you why. So for each input, there is only one output. So 3 outputs to 0, 4 to 1, 5 to 2, and 6 to 0. So really what I'm looking for is making sure that my x values do not repeat with different y values. It's okay if there's repeating y values. So if I put 3 into this function, I'll only ever get 0. If I put 6 into the function, I will only ever get 0 out. What would make it not a function is if I put 3 in and got 1 out, or 2, or anything else but its original output. So yes, this is a function because the x values do not repeat. It's okay if the y's do. Last one we have is a mapping. This is kind of like a table. So these are all our x values. These are all our y values, and it shows with arrows what the outputs are. So 1 output is 10, 2's output is 11, but it also has an output of 13. So right now I can already say this is not a function. In other words, my x values would repeat. I've got 2 with an output of 11. I also have 2 with an output of 13. So this is not a function. Okay. The vertical line test, so our next important term highlighted right here. This is a test that we can do in order to see if a graph is a function. So you can use your finger, you can use a pencil, a pen, whatever is vertical, and what you're going to do is run it from left to right, and you're going to see at any given time, does my pen or pencil hit the graph or intercept it at more than one point? So as I run this along my graph, you'll notice there's only ever one point where it hits the graph. So yes, this is a function. Let's try this one. So move left to right. You'll notice when I run it through this graph, I'm hitting it at 2 points all the time. So this is not a function. You would say this fails the vertical line test. And one more. Running it through my graph, this is only ever hitting that yellow line at 1 point. So yes, lines are functions. Okay, Next few terms, let's zoom out or in a little. We've got continuous versus discrete. So continuous graphs, these are graphs that are single unbroken curves. So this is continuous, this is continuous. It's kind of in the word. It continues, it doesn't end or break up. Discrete graphs is a graph that is not smooth and continuous. The points plotted have spaces between them. So there's not, one point immediately after the other. You can see it's almost like a dot graph. There are other examples too, but these are the most common discrete graphs you will see. So up here are continuous, down here are discrete. Last two really important terms are domain and range. So just reviewing, making sure that we know domain is a set of all x values for a relationship or function, and range is the set of all y values. Okay? All right, let's do some practice. We're going to state the domain and range for 3 different functions, and we are going to see how we write those. So I'm going to change up my color, and let's start with the first one. So when I talk about domain and range, I'm just going to use a shorthand. I'm just going to say D for domain, R for range, and then we're going to use some fun curly brackets to put the values in. So for this table, I only have these 1, 2, 3, 4, 5 x and y values. So those are the only numbers that are going to be in my domain and range. Okay, so my x values, my domain, are going to be 2, 3, 4, 5, and 6. And that's it. No values in between, no values that are greater or less than, just those 5. Same thing with my range. 3, 4, 5, 6, and 7. 6 and 7, those are my range. So all I did was just list the x values for domain and the y values for range. All right, next one, a little different here. We've got, again, a linear function. This would be a line on a graph. Now, if we were to graph this, it'd be a little easier to see. But when I have a linear function like this, I can input any x value and I will get any y value out. So if I were to graph this, I would have, let's see, I'd have a graph that kind of looks like this. Okay, so negative slope pointed to the left, kind of flat. And this line would go forever up and over, and it would go forever down and over. So what that's telling me is that all x values and all y values are included. So for domain, it's all real numbers. And same thing for range. Another way to say this, if you don't want to write this all out, we write this fancy R with 2 lines. So these both mean the same thing. It just means all values. Okay? Next one, I'm going to think about this again logically. My y values and my x values. My x values, I can input any value in here. Any value works. I could put -3, I could put +4, I could put 1/2. So for domain, any value works, all real numbers. For range, or my y values, let's think about this. If I were to put any value in, the absolute value of any number would give me a positive number. So I'm going to say that my y values start at 0 and go to infinity. So from 0 to infinity, that includes everything that is positive. If I wanted all numbers that were negative, I would start at 0, or I'm sorry, I would start at negative infinity and go to 0. So this just tells me all positive values. Okay, moving on. We are going to graph functions using a limited domain. So we're only going to graph using the x values that have been provided. Okay, let's start with the first one. So we've got y equals 3x minus 1. So what this tells me is instead of using the steps from skill number 7, so instead of starting with the y-intercept, using the slope to plot a few points, connecting the dots, we are only going to input these 4 x values right here. So let's write our work for that, and then we will graph those 4 points that we get. Let's start with 3. So y equals 3 times, and then I'm going to put 3 in for x. So this gives me 9 minus 1, which is 8. Okay, so my first point is 3, 8. I'm going to plot that on my graph. I don't have numbers, but we're just going to eyeball it. So over 3 and up 8. Okay, next one, I'm going to do it with 2 now. So y equals 3 times 2 minus 1. This is 6 minus 1, which is 5. So my next point is 2, 5. And I'm going to plot that. So over 2 up 5, somewhere right here. Next one is 1. So y equals 3 times 1 minus 1. That's going to be 3 minus 1, which is 2. So this point is 1, 2. So let's graph that. Over 1 up 2. Okay, and then last one, really easy, 0. If we 3 times 0, that's just 0. And then subtract 1. So my last point is 0, negative 1. I'm going to plot that. 0, down 1. Okay, so you'll notice they're a little off, but you can see this is linear, but we do not connect the points. We only graph those 4 points we got, and that is it. So that was a limited domain. Okay, let's try it one more time. This time we only have 3 x values, and we're going to find what those points are given those x values. Let's start with the first one, 2. So I've got y equals negative 1/2 times 2. This is like 2 divided by 2, and then with a negative. So 2 divided by 2, that's 1, the negative, and then plus 1. This is 0. So this point is 2, 0. Let's plot that. So over 2 up 0. Okay, next one is 4. So y equals negative 1/2 times 4 plus 1. This is like 4 divided by 2 with a negative. So that's negative 2 plus 1, and that is negative 1. So this point is 4, negative 1. All right, let's plot that. So over 4, down 1. And then last point is 6. So y equals negative 1/2 times 6 plus 1. This is like 6 divided by 2 with a negative. So this is negative 3 plus 1, and that's negative 2. So this last point is 6, negative 2. And we'll plot it. Over 6, down 2. Again, do not connect these because we were only graphing for these 3 x values. Okay, thanks so much for watching, guys, and you can get started on your practice now for skill number 8.